We're going to have a look at how to use this simulation waves intro. And basically, as it suggests, it's an introduction to waves. There's lots of different types of waves. There's sound waves, light waves, earthquake waves, water waves, and so on. And let's have a look at some of the different types. And when you go to resources at the PHET website, you've got these things here, which I have on my database as well, where you can open them up and so on. It tells you a little bit about how it works, tells you some information if you're a teacher. So there's a lesson I could get from here. Lessons in different languages as well, by the looks of it. And you got some translations. There's related simulations, so I could go to other simulations. Yeah. Anyway, let's give it a go. So we'll just load this up. Right. So this is quite cool. So we're actually going to be looking at water, sound, and light. And I think what they're going to do is they're going to show the similarities. So let's look at water first, because that's the easy one. So what do we get? If we click on, yeah. So basically we've got drops of water dropping into it, and it's making these ripples. Now at the moment we're clicking on the top view, but what does it look like from the side? So from the side it looks like that. Right. Now, so what's really going on here? Well, I can pause it. I can use the simulation and I can measure the distance from one place to another, as long as I keep it horizontal. And if I measure from the top to the top, that measures 2.7. If I keep it out and do the same there, you'll find it's the same with each one. Now, what that is, that's the wavelength. We were talking about wavelength, and we talked about when we looked at light, we can detect certain wavelengths of light. Well, these are the wavelengths again, but now it's obviously a water wave. So this is what the water wave would look like from above. And you can also, what else can you do with this? You can, so what's this measuring? This is measuring the water level. So you can measure the water level at two different places. But I'm just trying to understand, why can't I see? Are you able to see two colors there? It might be my monitor. I can only see one line. Can you see two lines? Right, so I think I need a new monitor. I can't really quite make out the other one. I can see the circle going up and down, but I can't see the other color there. If I move it onto my other monitor, maybe I can see. 1 second. I can't pause it when it's down there for some reason on this thing. Okay, in any case, if you've got a good monitor, unlike mine, you'll see the different lines. And you can just measure just one of them if you like. And now it's just showing how the water level is changing over time. If I do it nearer there, you can see the amplitude is greater. And so in fact, I want to, yeah. So the amplitude is greater. Now that means that as it goes along, the amplitude reduces. Now, if we look at it from above, we can see the reason why, because it spreads out. So the power or the energy of the wave spreads out the further away you get, okay? So we normally look at waves, when we're studying about waves, we normally look at it side on. So let's just see, what else do we have here? We've got, this is quite cool. This is a graph. So this is, well, I imagine you can see that this graph looks the same as the picture. So I imagine if I click that and graph, now we've got them both at the same time. So we're measuring again how the water wave is changing. We've also got a stopwatch if we want to play around with it. So we want to say, how long does it take for one of these waves to get to the other side? We can start it and time how long it takes. And then we can change, what else can we do? We can change the frequency. If I increase the frequency, what do you think will happen if I increase the frequency? What will happen? So we've got to be careful what we mean by fast, because if you mean how... Yeah. So the speed at which it takes a wave to go from left to right, that will stay the same, I think. But the how often how often the drops fall, that's going to increase. So if I change that, now that the drops are dropping in a bit more quickly, and when that happens, the wavelength gets shorter, and that sort of makes sense because the wave hasn't had as much time to get away from the tap before the next water droplet goes inside, drops down. So if you turn the frequency down, now the drops don't happen as often, and so the wavelength increases and so on. So this is a really good way to just introduce and experiment how do waves work, and we can also see from here that as if I change the amplitude, yeah, of course, yeah. So I'll just briefly wrap up though the video just to show you that with sound you can do the same thing as well. So you can experiment with that, and you'll probably find that it's very similar sort of thing. It's just basically showing the parallels, and then with light, it doesn't. That's not the way that we see light, but that is the way that light is, believe it or not. And you can again, oops, oh, something went wrong there, didn't it? Oh, I see. I know why. Because with a light wave, it's actually happening in all directions, of course. Okay, I see. Anyway, so I will stop the video there because I think it pretty much explains it, and I'll save it in the simulation.